Hey everyone, Justin here with Elastic. Just wanted to show you real quick how to run the Jupyter notebook that's included with Jeff Vestal's fantastic article on Search Labs titled Vector Search and KNN Implementation Guide API Edition. I'll throw a link in the description below to find this article, as well as the repository where this notebook lives. And if you're wanting to get a bit more into the weeds of the methodology and vocabulary, I'll include an introductory article I wrote that gives a decent overview of just about everything you need to know about vector databases. Throughout the process, I'll call out a few things I think are of particular importance when getting into vector search, and some reasons some of the steps were taken in this article. We begin by ensuring that the necessary dependencies are installed. Run the following command to install the required Python libraries. These packages enable us to connect to Elasticsearch, leverage pre-trained models, and process embeddings efficiently. To securely connect to your Elasticsearch deployment, we'll use the getPass module to input sensitive details like your API key and endpoint. Here's how it's set up. With the credentials in place, we can establish a connection to Elasticsearch. If the connection is successful, you will see details about your Elasticsearch cluster. Next, we import the Hugging Face model into Elasticsearch using the eland import hub model command. This command registers the specified model in Elasticsearch and prepares it for text embedding tasks. With the model successfully imported, your Elasticsearch instance is now ready to generate vector embeddings for text. Okay, the first step in this process is configuring the inference pipeline. This pipeline utilizes a pre-trained embedding model from Hugging Face, Sentence Transformers, All, Distill, Roberta, V1, to convert text into vector representations that Elastic can use for similarity searches. So we define this pipeline to map our input text field, myText, to the model's expected input, output the resulting vector to a specific field, myVector, and then we handle any errors gracefully. And then we call es.adjust.putPipeline, throw in our vector embedding demo as the name, enter pipeline in our body, and there we go. This ensures that any documents passing through this pipeline are automatically enriched with their corresponding vector embeddings. Next, we define an index template, which acts as a blueprint for any indices matching the pattern myVectorIndex*. This template specifies a dense vector field, myVector, with 768 dimensions for storing the embeddings, text field, myText, for the original text, and source exclusions to prevent storing the vector redundantly in the source field. When you actually call and search for these results, you don't actually want the entire vector sent back to you. That's 768 individual float values. That's a lot to send back to you, so we're just going to exclude those. We call es.indices.putIndexTemplate and then throw in the name, and there we go. This establishes a consistent structure for your vector-based data. Okay, with a pipeline and template in place, it's time to index the data. For this example, we're indexing some memorable quotes from The Big Lebowski. The data is inserted into the index myVectorIndex01 using Elasticsearch's bulk helper. This ensures that all records are indexed efficiently in a single operation. Refreshing the index ensures the data is ready for immediate querying. Now we move on to searching the index data. Using Elasticsearch's vector search capabilities, we'll explore several search scenarios. Basic KNN Search. This is the simplest use case, finding the closest match to a query based on vector similarity. Here we provide a text input, watch out, I have a drink, and Elasticsearch computes the most similar documents based on the pre-trained embedding model. Check out the search configuration. Field, myVector, K1, num candidates 5, query vector builder, and the object with the query. This retrieves the single most similar document from the dataset. Okay, hybrid search, which is KNN plus our regular search. In this case, we combine traditional text search BM25 with vector search for enhanced results. The query matches text that includes the word bowling, and the KNN search identifies documents similar to the embedding of he enjoyed the game. The addition here is the query parameter of query equals match myText bowling. The results are ranked using reciprocal rank fusion, which merges the BM25 and vector scores to determine the final order. Filtering results. Sometimes you need to filter results based on additional criteria. For example, we can restrict the search to only include quotes attributed to the dude. This is done by adding a filter condition. Filter, term, mymetadata.keyword, the dude. This ensures that only documents meeting the specified condition are returned. Aggregations with KNN. Finally, we can combine vector search with aggregations. This allows us to group the results by specific fields, such as the speaker. For instance, while searching for quotes similar to "Did you bring it?", we can also aggregate the results by my metadata to see how many matches come from each speaker. You'll see at the ags variable, there's metadata, terms, field, mymetadata.keyword. This retrieves the top hits along with the grouped metadata. With these steps, we've built a complete workflow for vector search. We configured an inference pipeline for embedding generation. We created an index template to standardize mappings. We indexed data and enriched it with those embeddings. And lastly, we queried the data using basic KNN, hybrid search, filters, and aggregations. This process demonstrates how Elasticsearch can perform powerful similarity searches with minimal coding overhead. Whether for text, images, or other data types, Elastic has your back. Thanks for checking out this video, and I hope to see you again soon.